is Anna McCullum. Joining me in this session is Sumesh Balakrishnan. We're from the product management team, and today we'll be talking about how you can monitor Oracle databases in AWS with Enterprise Manager. We know many of our customers use Enterprise Manager for monitoring and managing their fleet of Oracle databases. These Oracle databases can be deployed in their on-premises data center, in Oracle's cloud, or in other clouds such as Amazon AWS. For today's session, we'll discuss how you can use Enterprise Manager to monitor Oracle databases running in AWS. We'll start with an overview of the different options for Oracle databases in AWS. Next, we'll talk about how you can set up network connectivity between Enterprise Manager and AWS, which is a basic prerequisite needed across all Oracle and AWS options. Then we'll go over monitoring considerations for each AWS option. And finally, we'll wrap it up with a summary of key takeaways. RDS is a relational database service in AWS or Amazon Web Services. In AWS, customers can configure to use the Oracle database in these three ways. The first, RDS for Oracle, is the option where AWS provisions and manages the Oracle database and provides a way for the user to optionally configure the Enterprise Manager agent. There is no host access provided with this option. In the second option, RDS Custom for Oracle, AWS provisions the Oracle database using the database installation files that you upload to AWS. In this option, you are provided access to the underlying host. To monitor the database in Enterprise Manager, you'll have to install and configure the Enterprise Manager agent. The third option involves provisioning an EC2 compute instance. This option is similar to the other options where you provision a host and install, configure, and manage the Oracle database and EM agent in a similar way that you would do for any host or compute instance. We'll look into these in more detail later in this presentation. But first, let me turn it over to Sumesh, who will discuss the basic prerequisite step of configuring network connectivity between Enterprise Manager and AWS.
As more organizations adopt hybrid cloud architectures, it becomes essential to have a unified monitoring solution that covers both on-premises and cloud environments. Also, it is crucial to establish secure and reliable connections between on-premises infrastructure and cloud environments. Here, we have on-premise system hosting enterprise applications, servers, databases, all running inside the private on-premise network. Similarly, the AWS cloud hosting enterprise applications, multiple services, and all running inside the private subnet. At a high level, to bridge the network connection between on-premise and AWS, we are showing the option of using the IPsec VPN connection. There are some configuration steps involved in connecting the on-premise and AWS network, such as creating the virtual private gateway and attaching it to the virtual private cloud on AWS, and then creating the virtual private network connection on the AWS cloud. Similarly, on the on-premise network, create the customer gateway device. And then once the customer gateway device is created, then verify the connectivity between the on-premise network and AWS. This is the documentation that details the entire configuration steps in order to connect your on-premise network to AWS. So in the hybrid cloud architecture, let's see how to create the network bridge between on-premise and AWS cloud, allowing Enterprise Manager running on the on-premise network to seamlessly connect to AWS cloud network for comprehensive monitoring of RDS databases running on AWS instances. Here we have Enterprise Manager deployed on the on-premise network, which is monitoring various target types deployed across data centers. In the hybrid cloud environment scenario, We have AWS Cloud hosting services such as RDS for Oracle, RDS Custom for Oracle, and Oracle Database running on Amazon EC2 instance. So to monitor the RDS Oracle database running on AWS through Enterprise Manager, which is deployed on on-premise network, the on-premise network needs to be extended to connect to the AWS cloud. Configuring the network between on-premise and AWS plays an important role for a seamless, secure data transfer between the networks. On the on-premise side, create the network gateway. A gateway is created, which is a physical or a virtual device located within your on-premise network. It acts as a bridge between the on-premise infrastructure and the AWS Virtual Private Cloud Gateway. The Virtual Private Gateway acts as the entry point for the VPN tunnel, ensuring secure communication between the on-premise network and AWS. The on-premise gateway handles the encryption and decryption of data transmitted between the on-premise network and AWS. So the virtual private gateway, you have to attach it to the specific virtual private cloud in AWS for secure connection. The virtual private gateway serves as the endpoint of the VPN tunnel within the AWS environment and allows secure connection from the on-premise network. It handles encryption and decryption of data transmitted between the on-premise network and AWS. Now, the IPsec tunnel is established between the on-premise gateway and the virtual private gateway, providing a secure and encrypted connection between the on-premise infrastructure and the AWS, ensuring secure communication and data transfer. And with on-premise gateway and virtual private gateway connected via the IPsec VPN tunnel, Enterprise Manager deployed on the on-premise network can efficiently monitor the health, performance, and availability of databases running in AWS Cloud. And this means you can centrally monitor and manage your databases, which is deployed across your on-premise and AWS, allowing for a seamless integration and unified management experience. So here we have the agents deployed across RDS for Oracle, RDS Custom for Oracle, and on Amazon EC2 instance. So all the agents securely connect to the on-premise Enterprise Manager through this secure VPN tunnel. So at a high level, this is the network topology in order to bridge the network between your on-premise and AWS cloud. As more organizations adopt multi-cloud strategy, again, it becomes crucial to establish secure and reliable connection between the cloud environments. In this scenario, Oracle Cloud Infrastructure, which is OCI, hosting enterprise applications, databases, servers, all running inside the private subnet. The AWS Cloud also hosting enterprise applications, multiple services, all running inside the private subnet. At a high level, to establish the network bridge between OCI and AWS for secure monitoring, we are using the IPsec VPN connection. To create the network bridge, there are configuration steps that are required to be done on the OCI and AWS side. So here, there are some steps involved in configuring the network connection between OCI and AWS. One of the steps is to first create the temporary customer gateway, and then create and attach the virtual private gateway, and then create the VPN connection on the AWS cloud, and then download the configuration. And on the OCI side, you have to create the customer premise equipment, which is the CPE, and then create the IPsec connection. And again, on the AWS cloud, you have to create a new customer gateway and then modify the VPN connection for the new customer gateway. And then finally, verify the connectivity between the OCI and AWS. And this is the documentation that details the entire configuration steps on how you can extend the OCI network in order to connect to AWS using IPsec VPN. So here, as business continues to embrace the cloud, many organizations are realizing the advantages of adopting multi-cloud architecture. In the multi-cloud architecture, let's review on how to create the network connectivity bridge between OCI and AWS in the context of Enterprise Manager. We have Enterprise Manager deployed on the OCI through the OCI Marketplace app. It's a multi-OMS deployment with the repository database, and OMSs are in private subnet, and load balancer is in the public subnet. An Enterprise Manager on OCI is monitoring the cloud targets. And here we have AWS Cloud that is hosting services like RDS for Oracle, RDS Custom for Oracle, and Oracle Database running on Amazon EC2 instance, all running inside the private subnet. Network connectivity between OCI and AWS can be achieved through various methods depending on the specific requirements of the organization. OCI and AWS both supports VPN connectivity, allowing secure communication between the two environments. This involves configuring IPsec VPN tunnel between the VCN in OCI and the VPC, which is a virtual private cloud in AWS. VPN connectivity provides encrypted and private communication channels. And one of the commonly used methods for connectivity between OCI and AWS is the use of IPsec VPN connection. So at a high level, on the OCI configuration, create a dynamic routing gateway, which is the DRG in OCI, that will serve as the VPN endpoint. So create a route table and update the routing rules to direct traffic for the AWS VPC towards the DRG. And provision and configure the customer premise equipment, which is the CPE device on the OCI side. Ensure that the CPE is connected to the appropriate network interfaces and routes traffic correctly. And then set up the IPsec VPN connection on the CPE using the VPN parameters provided by OCI and AWS. Now, configure the IPsec connection within the DRG, providing the necessary VPN parameters, including the customer premise equipment public IP address, encryption algorithms, and authentication details. Similarly, on the AWS cloud, create the virtual private gateway in AWS, which will serve as the VPN endpoint. So configure the VPN connection in AWS, specifying the same IPsec parameters used in OCI, including encryption algorithms, authentication methods, and pre-shared keys. Also, update the AWS Virtual Private Cloud route table to include a route for the OCI network, directing traffic towards the Virtual Private Gateway. So the IPsec VPN tunnel provides a secure and encrypted connection between OCI and AWS VPC, ensuring secure communication and data transfer. With the CPE and Virtual Private Gateway connected via the IPsec VPN tunnel, Enterprise Manager can efficiently monitor the health, performance, and availability of RDS Oracle databases in AWS environment. The secure and encrypted nature of IPsec tunnel ensures that the sensitive data remains protected during transit, addressing concerns about data security and compliance. To get the unified view of all RDS Oracle databases running on AWS, deploy and configure the Enterprise Manager agent on RDS Custom for Oracle, Amazon EC2 instance to securely connect and communicate to the Enterprise Manager running on OCI. Now that the network connectivity is established between the OCI and AWS, or between on-premise and AWS using IPsec VPN, let's look into how to monitor RDS Oracle databases on AWS with ease using Enterprise Manager. To discuss more on the monitoring part, let me turn it over to Anna McCallum.
Now let's take a look at the first option, RDS for Oracle. In this option, the Oracle database is provisioned and managed by Amazon RDS. Its supported versions include 19C and 21C, and we've also included a link to their documentation on supported versions. They also indicate the list of features that are not supported, such as ASM and RAC. For your reference, we've also included a link to their list of supported and unsupported database features. In this option, note that there is no access to the underlying host. For this RDS option to work with Enterprise Manager, you'll need to add the Amazon RDS OEM_agent option to configure the Enterprise Manager agent. Refer to their documentation on how to set this up. Sumesh also provided the network topology of how it would look like after you've configured the agent. At the end of the setup, make sure the agent is up and connecting to Enterprise Manager. You can verify this in the EM console by reviewing the agent status in the agent homepage. There are some documented limitations using the RDS OEM_agent option. These include not supporting administrative tasks that require host access, such as job execution and database patches. It also mentions that host metrics and process listing is not guaranteed to reflect the actual system state. Auto discovery of the database is not supported, so you'll have to manually add the database targets. Also, there is no access to the alert log, hence you can't view the alert log or use any of the alert log metrics. They also provide details on how to discover the database in Enterprise Manager. At a high level, you'll have to first unlock the DB SNMP account and then manually add the database target using the EM console. To manually add the target, you can first retrieve information about the database from the AWS console, and then use these to fill in the required properties during database discovery in Enterprise Manager. After discovery, you'll find that you can use most monitoring features on this database. You'll be able to monitor and generate alerts using most metrics, except those that require host access, such as the alert log metrics. You'll be able to use the familiar EM features such as metric extensions, administration groups and monitoring templates, incident management and event compression, notifications including ticketing, dynamic runbooks, and blackouts. You can also access database performance features such as Performance Hub, Ash Analytics, and use other database admin operations based on the privilege of the AWS provisioned user called admin. Now let's take a look at the second option, RDS Custom for Oracle. In the RDS Custom for Oracle option, you provide the Oracle database installation files, which is used by Amazon to provision an Oracle database for you. Supported versions include 12c, 18c, and 19c. You can follow the AWS documentation for details on creating the Oracle database. This option allows access to the underlying OS and database environment. To manage this database from Enterprise Manager, you'll need to install the EM agent on the AWS compute instance using the same procedure that you would use if you were installing the agent on any host. After installing the agent, you can discover the database using any discovery option: auto discovery, guided discovery, or manual discovery. Once discovered, you'll be able to leverage a larger set of monitoring features in Enterprise Manager. This includes all of the features supported for RDS for Oracle, plus jobs and corrective actions and OS-based features such as alert log monitoring, OS command, and SQL script jobs. You'll also have the full set of host monitoring features, including the ability to use the run host command feature from the console. Let's talk about the third option, using EC2. In this option, AWS provisions EC2, which is an AWS managed compute environment, which you can use to install and manage the Oracle database. To manage this database with EM, you'll first install the EM agent in the same way you would do for any host. Then discover the database using any of the supported discovery workflows. After discovery, You can use all EM database monitoring and management features, as well as all EM host monitoring features. Here's a summary of all of the options we've discussed. In RDS for Oracle, AWS provisions and manages the Oracle database and EM agent. There is no host access with this option. You'll be able to monitor this database in EM with some limitations. Features that require host access, such as alert log monitoring and OS jobs, are not supported. In RDS Custom for Oracle, AWS provisions the Oracle database using the database installation files that you provide. This option does give you access to the host. To monitor this database in EM, you'll need to install the agent and then discover the database using any supported discovery workflow. With this option, you'll have full database monitoring, be able to access performance diagnostics and admin features based on the privileges of the database user. You will also be able to leverage EM's host monitoring features. Note the versions of the database supported with this option. The last option, EC2, is about using AWS for its compute instances. This option is the same as having access to a host where you can install the Oracle database and EM agent. Then once the database is discovered, you will have access to all of EM's database monitoring and management features, including all host monitoring features. In summary, you can see that Enterprise Manager can be used for multi-cloud environments. For AWS specifically, first make sure you set up network connectivity between EM and AWS following the guidelines discussed by Sumesh. Then based on the AWS option used, you'll need to follow the option-specific instructions for discovery of the Oracle database in EM. Once discovered, you'll be able to monitor the Oracle database using most, if not all, Enterprise Manager monitoring features. Hence, your existing EM monitoring setup, which may include the use of administration groups of template collections, metric extensions, using groups in your incident rule sets, all of these should work seamlessly with your Oracle databases in AWS, enabling you to continue to use EM as your single monitoring and management tool for your multi-cloud Oracle estate. Thanks for joining our session. Here are links to our website, videos, and additional resources on Enterprise Manager.